Let's see the next question in this exercise, question 818. If 3 cot A is equal to 4, and then we have been given some expression involving tan, cos, and sine of the same angle, we are supposed to check whether the expression is true or not. So we will actually compute left hand side. We will also compute the right hand side and we'll check whether they are equal or not. This expression requires evaluation of tan, cosine, and sine of a particular angle. And we have been given one relation about cot. So first, let's try to bring it as simplified as possible. 3 cot A is equal to 4. Cot A, we will take 3 on the opposite side. 4 over 3. Now, cot and tan are reciprocal ratios of each other. Tan is 1 over cot, or cot is 1 over tan. So getting tangent ratio from cotangent ratio is not a big deal. We'll simply have to reciprocal the given fraction. So we will switch the numerator with denominator and we'll get the reciprocal, which is tan of A. Instead of 4 by 3, now we'll get 3 by 4. Why? Because cotangent and tangent, they are reciprocal ratios of each other. From this information, can we find out the remaining two ratios, sine and cosine? Let's try. We know that tan is opposite over adjacent. So that means if opposite is 3, adjacent will be 4. We are going to construct a right angle triangle whose opposite is 3 and adjacent is 4. Let's do that one. So this is a right angle triangle. Let's assume that this is the angle under consideration. For this angle, this is the opposite, this is adjacent, and this is hypotenuse. So we are going to mark opposite as 3 because it's coming from here, adjacent as 4 because it is coming from here, and hypotenuse can be easily found out using Pythagoras theorem. So that would be 3 square plus 4 square under square root. So that will come out to be 5. Now we know all three sides of that right angle triangle. So we can easily find out sine and cosine ratio. Sine, we know that opposite over hypotenuse, that would be 3 divided by 5. Adjacent, cosine is adjacent over hypotenuse, that's 4 upon 5. And tangent we have already calculated, 3 over 5. Now we have all three ratios ready. We can substitute these ratios on the left hand side first. So let's take the LHS, which is 1 minus tan square A upon 1 plus tan square A. We are going to substitute the value of tan A, which is nothing but 3 divided by 4. Let's take the square. 3 divided by 4 square will be 9 upon 16. We are going to write down that in the numerator as well as denominator. Once we cross multiply, this will be 16 minus 9. So that will be 7 upon 16. And this will be 16 when cross multiplied plus 9, that will be 25 upon 16. We realize that upon 16 is common. We can cancel that from numerator and denominator. So our answer for the left hand side simplified version will be 7 upon 25. Let us try for the right hand side. The right hand side is cosine square A minus sine square A. We know the cosine A is 4 upon 5. Sine A is 3 upon 5. So when we square them, that would be 16 upon 25 minus 9 upon 25. The denominator is common. It's already same. We don't have to do anything. Just subtract the numerators. That would be 16 minus 9, which is 7. 7 divided by 25. We realize that LHS and RHS both come identical. So we say that this expression is true. LHS equal to RHS.